Okay, so we are on part 2 of our microscopic anatomy of the endocrine glands. So we are going to continue on with the pituitary gland next. Now, the pituitary gland we know is separated into anterior and posterior pituitary. The anterior pituitary gland and the posterior pituitary gland are going to look different microscopically. So you can sort of zoom out and you can see that they do look different here. Okay, this is only at 40 times. So we're going to see this glandular anterior pituitary and this neural posterior pituitary. And as we zoom in, we can start to see larger differences here between the two. Okay, the anterior pituitary has a very distinct separation from the posterior pituitary, which is nervous tissue. Anterior pituitary is this glandular tissue. Now we're going to get a little bit closer even than this by using the pictures that are in the lab manual, but I did want you to see the difference between this glandular anterior pituitary and this neural posterior pituitary. You can see the cells here. We'll see the different staining in a minute when we get a little bit closer, but the acidophils and the basophils, which are going to be producing are hormones in the anterior pituitary versus this neural tissue in the posterior pituitary. So now we're looking zoomed in on this anterior pituitary, and the acidophils and the basophils are going to have a different staining to them. Now we call the acidophils pinkish staining. I'm not quite sure they look like that. Maybe it's my screen or this picture, but the basophils are darker and the acidophils are going to be this lighter color. Okay, pinkish staining. The basophils typically have like a bluish color staining to them. You can see the difference. Now, the acidophils are going to be responsible for producing prolactin and the growth hormone, and the basophils are going to be responsible for producing all of the trophic hormones. So your thyroid stimulating hormone, your follicle stimulating hormone, all of those hormones, those other hormones that are coming from the anterior pituitary, those trophic hormones will be produced by these basophils. Now, the posterior pituitary looks very different. Again, it's this neural tissue. The hypothalamus is producing the ADH and the oxytocin that will then be stored in this neural tissue of the posterior pituitary. Okay, so we have some neural tissue in here. We have our pituocytes, but our hypothalamic neurons that are producing the ADH and the oxytocin will then send it to this posterior pituitary for storage. So there's not production going on here. It's just a storage before secretion. So with everything else that we're talking about with the endocrine glands, we do need to address the disorders. The anterior pituitary, posterior pituitary disorders are going to be ones that affect the body in an immense way. The anterior pituitary, if you have growth hormone over or under production, or possibly growth hormone production in a unpredictable pattern, then you're going to see things like the acromegaly or the dwarfism we talked about in the previous recording. If you have a disturbance with the ACTH production, then we're seeing what's called Cushing's disease, which is excessive steroid hormone that's called cortisol, and that's going to be the over secretion of your ACTH. You'll see sort of distinctive signals of Cushing's disease, which is very low blood pressure, a humping on the upper back, and the neck and the face, fat pad buildups. So you get these buildups around this area of the body, excessive hair growth, easy bruising, things like that come with it. Now, if you look, we will talk in a minute, we're going to talk about Addison's disease as well, which is sort of the opposite of the Cushing's, when we talk about the adrenal gland in a minute. But you could also have things like your polycystic ovary syndrome or precocious puberty that come from the LH-FSH imbalances. Your hyperthyroidism is obviously tied back to the anterior pituitary. The inability to lactate comes from the lack of prolactin being released, things like that. So there's a lot of tie-ins to that anterior pituitary. And then the posterior pituitary, we're having our ADH and our oxytocin. right? So ADH, especially inadequate levels, are going to cause severe dehydration, really high sodium levels, which means excessive thirst. It's called diabetes insipidus. And levels that are too high of our ADH are going to cause water retention and really low sodium levels. Remember that our sodium levels, whether it's hyper or hyponatremia, are going to be caused by too much or too little fluid, right? The body is going to have these changes to the concentration gradients dependent upon how much fluid is present in the body. So we remember our adrenal gland. This is our last one we're going to look at here for activity 2. The adrenal gland has that pyramidal shape. It sits on top of each kidney, so 2 adrenal glands, 1 per kidney. And it is also called the suprarenal gland sometimes, right? Renal is kidney, so the top of the kidney makes sense, right? The adrenal gland has a cortex and it has a medulla, so you can see the difference here. This capsule surrounding the cortex on the outside and the medulla on the inside. Now, if you look at a cross-section here of the adrenal gland, you can see, again, same thing. You have this capsule, this fibrous capsule that's outside, and then you have your medulla inside of this cortex area. I'm going to go back and forth to another slide a little bit, but I do want to show you the adrenal medulla here, right? We talked about the adrenal medulla releasing the epinephrine, norepinephrine in that part of that autonomic nervous system reactions, right? That's your adrenaline, right? Your adrenal medulla releasing the epinephrine, norepinephrine. And you can see there's more of a clumpy appearance to the adrenal medulla than there is to the cortex area. Now this cortex area, you can see, again, the capsule on the outside, and then there's zones to the cortex area. Okay, so you have these different zones and they're different layers and they're very distinct compared to the medulla and this sort of clumpiness of the medulla here. So again, this medulla, the cells are a little bit more clumped together, and that is your epinephrine, norepinephrine area. So when we look at the difference between the adrenal medulla and the adrenal cortex, we have to see the difference, right? We can see the very clear difference in the arrangement of the cells. But the cortex is also arranged in these zones, and you can see the differences, right, in the arrangements here. The zona glomerulosa, this outer layer by the capsule, this is going to be this sort of spherical clusters of cells, and that's where your mineral corticoids are going to be produced. The zona fasciculata, this middle layer deep, okay, we're going in towards the medulla here. The zona fasciculata is going to be more of a parallel arrangement, and I'm going to show you the next slide. They're a little bit easier to see, but you can see the sort of parallel arrangement here. And that's where your glucocorticoids are going to be produced. And the inner zona reticularis has a little bit more of a branching pattern to it. That's where the sex hormones are being produced. So if we look here, again, at these zones, you can see that this outer zona glomerulosa, they're sort of clustered together, right? So the cells are kind of clustered in these little spheres together. Now, those mineral corticoids are going to be mostly aldosterone, and this zona vesiculata, where the parallel, you can see these kind of parallel lines, right? So your zona fasciculata, these parallel lines, the glucocorticoids, we're talking about cortisol here. And then the zona reticularis area, this inner area, it's kind of branching, so you can see it's not as typical as the zona fasciculata parallel pattern. It's more branching. And your sex hormones are going to be mostly aldosterone, but then aldosterone can be converted into estrogen and testosterone as well. To touch in with the image that's in your lab manual, this capsule outside, okay, you can see this capsule here. And then the zona glomerulosa, you can see sort of clusters here, this more parallel lining of the zona fasciculata, and then this more branching areas of the zona reticularis above this clustered, really clumpy sort of adrenal medulla. Now, just with everything else, we do have to talk about the disorders for the adrenal gland as well, which we did talk about a little bit when we touched on The Cushing syndrome is the opposite then of Addison's disease. When the immune system attacks the adrenal glands, you're going to have this insufficient production of hormones. And weight loss, fatigue, really low blood pressure, it can be fatal as well. So opposite of Cushing's disease here, but definitely equally as dangerous to homeostasis in the body. And that wraps up our microscopic anatomy of the endocrine glands. Please, if you didn't already pause in between the two videos, head on over to the diabetes video and then do your associated experiment and make sure you turn in the work. Please save the PDF when you get there to the end of your experiment and you save all of your answers and everything. When you click on print or save, you have to go up to the right hand and do the drop down for the printer in order to find the save to a PDF selection. Okay, you can always print it and take a screenshot, but PDF is probably definitely easier to send along for your assignment grade. I will see you all soon. Thank you.